Welcome to video 3 of a 4-part video series concerning the National Water Model Learning Module found on Hyrolearn.org. My name is Easton Perkins. I am a student at Brigham Young University and a research assistant in the Hydroinformatics Research Lab. This video will be going over how to complete exercise number 3 in the National Water Model Notebook number 1, titled Visualizing Forecasts in Python. To access the learning module, type in your web browser Hyrolearn.org. This will take you to Hyrolearn's main page where you can search the National Water Model. Hit enter and click the icon to enter. Once you're here, the page looks something like this. This video assumes that you have already worked through the introduction, read through the module overview, read through section 1, and have obtained a brief history of the National Water Model, how it's progressed over time, and why it's so important for us today. Section 2, you've gone through this page, which is especially important for understanding how the National Water Model outputs work as far as the short range, medium range, and long range forecasts. Work through learning activity number 1, and this activity will be going over learning activity number 2. All right, so this first main page will set you up with Jupyter Hub Notebook. Work through this page to get set up on that with Hydroshare, creating an account, and we are gonna get right into it. All right, again, that previous page will explain how to access this. You're going to click here on Quasi Jupyter Hub. And we are here. Now your page might not look exactly like this, but you should at least see some links that say National Water Model 1, National Water Model 2, 3, 4. And we are in National Water Model 1. All right, once you're here, the notebook should look something like this and should be titled Visualizing Forecasts in Python. Hopefully you've already watched and completed exercises number 1 and 2. Those will provide a brief understanding of how this Python code works and all of that. Today we're going to be focusing in on exercise number 3. Scroll down here to the bottom. Exercise number 3 states, try plotting a short-range time series for 3 consecutive reaches of the same river. Try to pick a major river. You can choose whether or not to plot them on a single plot or 3 separate plots. How closely do the 3 forecasts match? Is there any recognizable trend from one to another? Try thinking about which reach is furthest upstream and which is furthest downstream. How might that affect things? All right, well, this video is going to work through exercise number 3 right now. All right, we're going to scroll up here to the top, and we are going to briefly run through each cell and explain very briefly on what it's doing. So we're running this first cell now. Make sure you hit run. If you don't hit run, if a number doesn't appear in those brackets, that means it didn't run and the code's not going to work for you. So this first cell is importing all the packages we're going to need. So xarray to organize the data, matplotlib to help us plot and be able to look at the data. We're going to come down here and hit run for this cell. This looks like big ugly code. It's really not too bad. All it is it's looking at the reach ID that we're going to put in a little further down, going and grabbing that data for that reach ID, and giving us our short, medium, or long range forecast depending on what we tell the code to go get. And it's giving us the data for all of those things. So pretty awesome stuff. Matplotlib, it's going to plot it for us. We're going to come hit run here. It's going to get our variables. Now in the previous 2 exercises we used this block of code. This was our meat and potatoes. However, in this one we're not going to be using this cell or this cell. Or this one. We're going to come right down here to this one. And it's actually the same thing, except for now we're able to plot 3 reach IDs and look at those three reach IDs and compare them, and compare and contrast the reach IDs, which is what we want to do. Okay, so exercise number 3 states that we want to go to a major river and plot them side by side so that we can compare and contrast them. So we're going to come back up here to our old faithful link that's going to take us to the water.noaa.gov/map. So come right here. It's right underneath the matplotlib icon, and click on it. All right, I understand. Sweet. Okay, again, hopefully you already have seen this page before, worked with it. If you haven't, go back and do that activity, learning activity number 1, found in the learning module, or go look at the previous 2 videos where I've worked extensively with this interactive map. All right, so we want to pick a major river. You can pick any river in the continental United States that you want. The bigger, darker lines, line thickness, or darker line, or purple has the highest flow rate, and then it goes down from there. So try to pick a river that has a bigger flow rate, so a major river. So the Mississippi River would be a good candidate. The Missouri River, any river that you want. I'm actually going to come here to the border of Colorado and Utah, and I'm going to use the Colorado River for our purposes today, which is not right here. That's the Green River, so which we could use that river too, a White River. Let's come down here to the Colorado River. There we go. All right, so whatever river you choose, feel free to not pick the same river I did. Go maybe pick one close to where you're from. And we are going to pick 3 reach IDs that are in sequential order, so right up against each other. So there's 3 right there. So let's pick this one first. Now reach ID, I've explained this before, but it's just like a barcode with produce at the store. It allows the machine to scan in the barcode and know exactly what you're checking out, so it can charge you the right amount of money. The same thing goes for reach IDs for rivers and streams. Each river has reach IDs, tons of reach IDs, and a reach ID is basically anywhere between where a stream inlet or outlet are located at. So you can see here, there's one here and there's one here, right? So this little sectional river is going to have a different flow rate from, let's say, this sectional river, or upstream from it, right? This section is going to be different. Pretty incredible stuff, but it's super important. So that's why there are 2.7 million reaches in the continental United States, and it's because of that concept right there. All right, so we're going to come in here and we need 3 consecutive reach IDs. So we're going to start right here. We got one here. We're going to come in here and copy. Let's make sure we get it just right. All right, copy that. And we're going to come back here to our code and make sure we're at the right spot here, right? So we want to paste it in the Cumberland River ID. Now, we could change the name of that to maybe be Colorado River number 1, section 1, whatever, which is fine, and Colorado River number 2, 3. But if you do that, you got to come in here and change your variables here. For the purposes of today, we're just going to keep the names. They're just variables, so we'll just have to remember which variable goes to which section. So we got the first one in there. We're going to come in here. We're going to click on the next reach ID, copy that one. All right, and we're going to hit our last one right there. Sweet. Control C. Okay. And paste it in here. All right, they're all in there. Now this is pretty nice. Maybe if you've done the previous 2 exercises, maybe you'll remember that we had to put our reach stream ID in here, or reach ID, same thing, and then plot it in a separate cell. Well, this one has it all included in the same thing, so it's going to plot it for us right now. So we're just going to hit run. And of course, this is going to take a little while because it has to go out, grab the reach IDs, the URLs, and then bring in all the data. So this is going to take quite a bit of time. Okay, and as soon as that runs, we should have our graphs pop up right out here. Sweet. There's our 3 reach IDs of that same section of river, you know, in sequential order. There we go. Sweet. But this really doesn't tell us a lot. They all kind of look the same. So let's scroll down here, and we're going to run this plotting device right here. And it's actually going to plot it all on the same graph for us. All right, so that's a lot better. Now we can compare and contrast what's happening upstream and downstream, right? So let's scroll up here. And let's remember what variables go to what, since we didn't rename them. So the furthest upstream is the Cumberland, middle of is the Red River, and the furthest downstream is the Little River. Okay, and it looks like the Little River, so furthest downstream, has the highest flow rate. The furthest upstream has the lowest flow rate, and then it goes up in flow rate. So basically, as we move up this way, the flow rate goes up. So that tells me that all these little rivers, if we come back here, all these rivers, so like this one right here is probably an inlet because our stream rate, our stream flow went up. Right here too, so Bitter Creek is probably a river that's coming into the Colorado River, and it's increasing the flow rate, as we can see on this graph. All right, well, that's it for exercise number 3. Hopefully that made sense, and we were able to understand everything that's going on here. Stay tuned for the video tutorial for how to complete exercise number 4 coming up next.